We need energy for our electronics, for our factories, for our lighting, for our cities. Every year, the amount of energy that we need grows, and it has enabled in the last century the greatest advances our species has ever seen. Until now, most of this energy comes from fossil sources, but these are growing more and more expensive, and their destructive impact on our climate more apparent. So we need to look for other, more renewable ways of generating our energy. We need to graduate beyond fossil fuels. Fortunately, sources like wind and solar have become very cheap to build, backed in large part by Chinese mass production. Today, they produce more power for humanity than coal does. However, they have a problem. They are what we call intermittent energy sources, which means that because they are dependent on the weather, they do not always supply us with energy. So, in order to bridge that gap and provide a buffer in between energy supply and energy demand, we need large-scale energy storage. One technology available to achieve this is hydrogen, which can be won from water through electrolysis when the energy supply is higher than demand. And then it can be transformed back into electricity in a fuel cell when demand outstrips supply. So how does this fuel cell work? What is the simplest form you can imagine for energy to take? It's a fire, right? And a fire needs three components. It needs some fuel to burn, it needs an oxidizer, and it needs a spark, something to get the fire started. Now, we need the same things in a fuel cell. Our oxidizer is oxygen, like with most fires. Our fuel is hydrogen, and instead of a spark to get the reaction going, we have a catalyst, like platinum. If we mix all of these things together, this is what the reaction looks like. 2 hydrogen and 1 oxygen molecule combine to form water and a lot of energy. The catalyst makes this possible at room temperature without needing very high temperatures. Right now, this may be producing a lot of energy, but that energy is in the form of heat and light. When it comes to energy, the most valuable form is electricity. So let's try and change this reaction to produce electrical energy instead. In order to do this, we have to split the fire in 2. So we have this combustion reaction, and we need to split it into 2 parts. First, let's take the hydrogen and split it into hydrogen ions, that is, protons, and electrons. On the other side, we can combine the protons and electrons with oxygen to finish our reaction. I know this just looks a lot more complicated, so why are we doing this? It is all about these electrons. The electrons really want to cross over from the hydrogen reaction to the oxygen reaction, and they have a lot of energy. So we tell them, no, you can't go across and finish the reaction. First, you have to do some work for us. We do this by making it so that the only way the electrons can cross over between the 2 reactions is by going through an electrical circuit to, say, charge up your phone. This way, the energy we get is mostly in the form of electricity, as well as some heat. Now, how do we get the protons across? The reaction can't finish if they are stuck on one side, but we can't let the electrons across, because we need them to go through the circuit. We can do this by putting a proton exchange membrane in between the 2 half reactions. This type of membrane is special because it only allows positively charged ions across, meaning that the protons can go through, but electrons can't. That lets us separate the 2 half reactions. Now, let's put all of this together into a fuel cell. In the final fuel cell, we have the hydrogen coming in, where it is split at the anode, an electrode with catalyst on it. The protons cross the membrane, but the electrons can't, so they are forced through the circuit, where we can use their energy. On the other side, the electrons and protons rejoin to combine with oxygen to form water. This is a slower reaction, so the electrode needs to be larger and has more catalyst. And so, by splitting the reaction that usually forms fire into two half reactions, we can control the type of energy that we get out.